Check, 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 check. Can you hear me? Hello. Okay, so getting ready for your test you have coming up. Let's take a look. The first thing that I'm going to ask you to do is balance an equation, something similar to this. If you don't get this right, the rest of your problem is going to be wrong. My light's going to be adjusting here over and over and over, so maybe I can change a setting here that'll fix that. I don't know. We'll see. Okay. Oh, no. Looks like it's going to want to do that. Let me adjust this. Okay. So what I like to do is write down the elements that you are given. In this case, it is what we have: hydrogen on the reactant side, sulfur, oxygen, and sodium. I'm going to write that for the product side. Let's do some counting. So I have 3 hydrogens on this side, 1 sulfur, 5 oxygens. Don't forget there's 2 on both sides, and 1 sodium. I'm also not on the page. Here we go. On this side, on the product side, I have 2 hydrogens, 1 sulfur, 5 oxygens. Don't forget to count both products there, and sodium I have 2. That's going to be a good place to start. So let me start by changing my coefficient here so that my sodiums are the same. That makes this 2. That's time to get up. Oxygen is now 6. Sulfur stays 1, and hydrogen is now 4. And okay, my hydrogens are not balanced, so let me step that in there, and that will make this 4. And I will have 2, 6. I know it just keeps moving. It is now balanced. The next question you're going to have to answer is a ratio question. So if you take a look, really simply, we're looking at sulfuric acid to sodium sulfate, and we see that the ratio is, all you're going to do is take the coefficients, these numbers in front, and create a ratio. In this case, you can see the camera slowly dropping. So let me pull this down a little bit and try to stay ahead of it. H2SO4 to Na2SO4. So sulfate will give us 1 to 1. 1 to 1, written like this. And sodium hydroxide to sodium sulfate is 2 to 1. Just like that. So that is for every 1 mole of sulfuric acid, you will produce 1 mole of sodium sulfate. For every 2 moles of sodium hydroxide, you will produce 1 mole of sodium sulfate. And that's how you do that. Let's take a look at the next one. Ooh, this one doesn't look fun. Let's see here. Let's move this up. How many moles of sodium sulfate can be produced from 24.6 moles of sodium hydroxide? Assume excess sulfuric acid. Okay. Well, we're going to use these ratios in this formula here. It's a one-step problem, mole to mole. So the first thing you do, always write down what you are given. You are given, let me move this up. You are given 24.6 moles of sodium hydroxide. I'm going to set that up to cancel. And I'm going to use my ratio of sodium hydroxide to sodium sulfate here, which is 2 to 1. And so for every 2 moles of sodium hydroxide, I make 1 mole of sodium sulfate. These cancel, and that is going to give me, looks like 12.3. Ta-da! Okay, let's take a look at the next question type. What is the molar mass of sodium sulfate? Okay, that's pretty easy. What am I given? Sodium, sulfur, oxygen. If I look at the periodic table, the mass for sodium is 23, but I have two of them. Sulfur is number 1632. I have one of them. And oxygen is 16 each, but I have four of them. And then I put this into my handy dandy calculator, which is actually my phone made into a calculator. And I get 142 grams of sodium sulfate for every mole. That's it. Just add them up. Okay, then it's asking me, as this camera rocks back and forth, how many grams were produced of sodium sulfate. I wrote it a little funky in part 3A. If you don't remember, it was 12.3 moles. So let me write that down, 12.3 moles. And I'm leaving the molar mass right here because we're going to want that. So now I got to set this up so that this cancels out. I have 1 mole. Abbreviating moles here, and that's 142 grams of sodium sulfate. Put this into the handy dandy calculator. Make sure these cancel. Calculator, calculator. Let's say here 1,746.6 grams. And that will tell us that. Okay, 4 or 5 are technically the same problem, so I'm only going to do number 5 and use that same technique for number 4. The numbers will change. It's just a gram to gram conversion. I'm asking you for the theoretical yield, how much sodium sulfate can be produced if everything in the universe worked out perfectly and we had a 100% efficient situation, which is never going to happen. So let's see what we could do. If you had 15.6 grams, because that's what I'm given, always write down what you're given. Your first step is to go, it's a gram to mole. You could do this in one big long equation, but let's do this step by step. I need to know how many grams of sodium hydroxide there are in every 1 mole of sodium hydroxide. That's the molar mass. So let me find that really quickly. I know that oxygen is 16, hydrogen is 1, sodium is 23. Let's see here, let's add that up. That gives me 40. Oops. Text messages are coming in. Let's see here. 15.6 divided by. So I should get 0.39 moles sodium hydroxide. Perfect world. That makes no sense. Yes, it does. Okay. Perfect. Now I have to do a mole to mole. So I take my 0.39 moles of sodium hydroxide, multiply it by the ratio. I know I'm going to need moles of sodium hydroxide on the bottom, so let me set that up so I make no mistakes. I look at the equation, which I have here, and my ratio of sodium hydroxide to sodium sulfate is 2 to 1, so that's 2 equals, and let me put that into the calculator. But I don't want moles of this. I need grams of this, so I got to go back from now moles to grams, and I'm going to use that molar mass of sodium sulfate that we used earlier, so that's 0.195 moles to SO4, and the molar mass was, I'll get that in a second here, 1 mole to SO4 is going to give me some grams of Na2SO4. And I know I have this written down, but I'll just do it again. $142, 27.69 grams. Oh, he's got to cancel. Of Na2SO4 sodium sulfate. And this is your theoretical yield. But 5B says, assume only 1.3 grams was produced. What is the percent yield? That changes everything. Well, let's see. We have 1.3 grams. So if I have 1.3 grams, the actual divided by the theoretical times 100 equals, let's put this in the calculator, 1.3 divided by 27. Don't forget to multiply by 100. It's going to be low. What do I get? Oh, 4.6948357. I'm going to round that off to 4.7 to make my life easy. 4.7% efficiency. Yahoo!